Hey, let's continue this week's tutorial with time loops and timestamps and so on. So in your project, in your lab, when you're running something, you might want to run a specific hardware for a duration of time, and you want to measure some specific parameters like temperature, pressure, speed, and so on at different time intervals and timestamps. So you need to have a counter, something that counts the seconds, minutes, or hours that are changing, or even days that are changing if you're running a system. So in this video, we're going to talk about how to define time loops and timestamps, and get the time, and all this is everything related to a time. So let's get started. On the block diagram, right click, and we have been using this folder, the timing folder, for quite a while using the wait function. So in the timing folder, there are like different kinds of functions that is related to time. So use this function for now, get date time in seconds, and put in the front panel. You can see that there's only one node that can be an indicator only. So right click on it and create an indicator. So you can see this is what is showing here. So after I used the get date and time function, and I have defined an indicator for it, I'm gonna see a current time. So now let's run it. So this says that today is the 20th of June that I'm filming this video, and the current time actually is 1:43 p.m. This is actually the time back in Clemson, but right now I'm actually in Berkeley, California, and the time is like 3 hours before that, so it's like 10:43 right now. So this function is gonna give you the current day and time. Like, you can look at my computer and you will see it's the current day and time. So looking at this wire here, you can see it's kind of like brownish, like thick brownish line. This is a waveform kind of signal, and let me show you what is a waveform signal. So I actually googled it, and a waveform data type in LabView is usually used to display and store periodic signal measurements. So if you have like a signal measurements that is like measuring different things, that's what it looks like. It's kind of like clusters, but it's not actually clusters. You have to change it to a cluster. So now let's get a component of this current time as a cluster out. You go right click, you go to timing, and this time you choose seconds to date time. So if I go to help for this function, you'll see that this function converts a timestamp value or a numeric value to a cluster of time values. So basically, if I wire this here, this is a timestamp kind of waveform data. And if I stay here and go to cluster and say unbundle by name, and choose that, and if I wire it to here, you can see that I will get the fractional seconds, and if I drag it down, I will get the second, I will get the minute, hour, day of month, year, and so on. If you want to go like scroll it down, day of week, day of year, and other things. But like, these are all the things that it will show for me. So now if I like create an indicator for each one of them, I should see each one of these components that is showing as like one big waveform data, or somehow like a clusters of data. I can see it all at different with different sections, and then you can use it as you wish. Like, you want to use it for some application, you want to know the exact day, you can use it as you wish in your program. So now let's run it. You can see that I'll get the fractional second of 0.8822, which is this. The second is 20, the minutes is 0, the hour is 2. Where's the hour? Oh, it shows 14. Why? Because it's 2 p.m. and 2 p.m. is actually 14. and then I'll get the month 6, the year 2019, and the day of the month 20. So that's what I want to tell you about this get date and time kind of function. And you can get as like these are all the information that you can get out of it, and it's really useful for your project, some applications that you have. But moving forward, I'm going to show you like different functions and how we can get like the time that is clicking. So let's get started on that. I'm gonna delete these parts of the clusters because it's too many informations here and it's getting cluttered. So I'm gonna delete this part and stay with this section, which is getting the current time. There is always some absolute day somewhere in 19. I'm not sure 1940 something, a year in 1940 something, that is actually the point zero for LabView, National Instrument. And from that day forward, if you count all the seconds, you will get an absolute time as seconds. And that's what it shows. So if you go to numeric and then go to conversion, there's one that says to double precision point. And click in here, it will get a number and change it to a double precision point. So if you get this waveform number and then connect it to DBL and then create an indicator out of it, this one is a double precision point, which is actually the absolute time. So let's run it. You can see like how big this number is. This is actually seconds after a specific day of a date. Actually, I'm gonna actually go and Google it and come back and tell you what day it is. Actually, I don't remember, so stay tuned. Okay, here it is. I just went to the help part of this function, and it says that LabView calculates this timestamp using the number of seconds elapsed since 12 a.m. Friday, January 1st, 1904, Universal Time. I have no idea why 1904, why not 1900, why not 2000, but that's the initial point. So basically, this absolute time that you see, which counts the actual time that we are right now, compared to the 1904 January 1st 12 a.m. and it's going to convert it to the number of seconds that had been passed. So that's the absolute time. It's like a really big number, and you can use that to calculate the time that is elapsing. So if I run this, I'm going to get the absolute time of that second that I just ran the program. On the other hand, if I have a while loop, so add a while loop in your block diagram, keep this timestamp out of the while loop, and then copy this timestamp again and put it inside the while loop this time. And add this DBL. So DBL was in the numeric conversion to double precision floating point. And then find another absolute value here. So that's absolute time, but this is like the initial absolute time. So basically, when we run this program, it first starts out of the while loop, so it will run this first. It will get the initial time when you start the program, and then it will come to the inside the while loop and get the time over and over again until you stop the program. So notice that we have errors here, and the error is because it's stop icon or the loop condition. So let's create a control for it so that the error is out. Now, what is the objective? The objective of me doing all these things is that I want to see the time that is elapsing. So I want to see every second the time clicks and ticks. So from previous videos and based on your experience so far with LabView, you know that if I don't add a wait function here inside a while loop, it's gonna run really fast and you cannot really see anything. You might want to do it that way. You might not want to do it this way. For the purpose of this video that I'm teaching you, because I want you to see how things are changing, I always add a 1 second or 1000 millisecond wait time. You might need a really smaller number or larger than that. That's just for the purpose of me showing you this. You will decide for your own project if you want the while loop run faster or slower. So I'm gonna add a wait time again for 1000 milliseconds, and I'm gonna clean this part a little. So this is the initial absolute time, this is the absolute time, this is the current time, and here is the stop button. Okay, so now if I run this is gonna run every second. You don't really see a change in the absolute value here because the number is so big and it's like 10 to the power of 9, and you don't see like one second passing every time. So you don't see that at all. And you don't see the changing time because this is outside a while loop. So once I ran this program, it will show me the current time, but it will not just the current time that I run the program. But because I haven't defined any indicator here, it's not gonna show me as time is passing. So let's stop this, and I'm gonna add create an indicator for this one here. So you can see that I'll have the initial time. I will call it the initial time for this one, which is here, and I will call this the current time because it's like while it's running, it's showing me the current time. And now if I run this, you will see how like time is clicking and passing like every second. So you can see how the time is clicking and passing. It's also changing in the absolute time here, but as I said, because the number is so big, you cannot notice that. So let's stop this. This is nice, this is really cool, but we want to see a counter that is only showing me every second that is passing. So how can we do that? I'll give you like pause this video and like think several seconds how you can define these timestamps and elapsed time. Actually, not timestamp, the timestamp, elapsed time. Just pause the video and think for a little. Okay, so this is how you'll do it. You'll go to the numeric and you choose the subtract. Why? Because I have the initial absolute time. I have the time that is passing every second, so I can get the elapsed time. So wire the initial absolute time to the y and the x to the absolute time. So why the absolute time? Because absolute time is the actual floating point number that I can subtract. I cannot subtract these two waveform kind of numbers because they're clusters of numbers and it doesn't make any sense. So you have to get a floating point number out of it. That's why we use the DBL to get a real like floating point kind of number and then subtract them. And now if I create an indicator here, I can call it elapsed time, and I will put the elapsed time here, and I'm gonna run it one more time. You can see now I'm having like 2, 3, 4, 5, 6, 7 seconds that is passing. Notice that it's not exactly 10 or exactly 11. There are some like decimal points number because when this program is running, it's not running like right away. It's just like several like really tiny like microseconds or milliseconds that is passing for the program to finish. So that's what it shows here because it's actually working with a real time. We are not adding a counter. We are actually looking at a real time and then subtracting the real time from the initial time. So that's why you see a little bit of like thing here that is like adding, so it's not exact. So that's one way of actually finding the elapsed time. There's also other ways that I'm gonna show you right now. If you go again to the timing function and this time choose a tick count, notice that it says tick count in the parentheses is milliseconds, so it's actually counting the milliseconds that is passing. So if I go to the help, you can see that it says returns the value of the millisecond timer. So it's based on milliseconds. Just notice that. It's important. We'll kind of do the same thing that we did with this get date and time function with the millicount, the tick count function. So I'm going to put one inside the while loop and one outside a while loop. Because this is in milliseconds, and we are running this program like this while loop every second, you have to convert the milliseconds to seconds so everything match up. So choose in the numeric function, choose the divide function and divide the value of the tick count to 1000. I'm not sure if I told you this or not, but I'll say it again. So see that these lines, these wires are blue here, here, and here. I don't know if I ever told you about the blue wires, but blue wires are integers. So they are just integers number. They are not floating point number like the orange numbers. You do the same thing here for the inside of the while loop. Like we have to convert the tick count from milliseconds to seconds, because we are running it every second. And it has to make sense. So we'll do the same thing again here by subtracting the initial from whatever that is happening inside a while loop. So I'll add a subtract, and this is what it is. So basically this is gonna measure the tick counts in milliseconds, and it's gonna the initial, and then it's gonna subtract it from the whatever that is inside the while loop. And I will create an indicator for it, and I will call this tick count elapsed time. Now let's run this one. You can see now this is like about the same. Again, you will see some numbers here. That's all because like the way that the program is running. And the tick count also look at like some absolute numbers. So let me stop this and show you what the tick count is actually. Like I will create an indicator in here after I have changed it to seconds. And it's right here, and I want to show you what it is. You can see that this is also some absolute values in seconds. So that's why like it's getting some absolute values also. So let's go to the help. It says that the base reference time is undefined. That is, you cannot convert millisecond values to a real world time or date. Be careful when you use this function in comparison, because the value of the millisecond timer wraps from this much to this much. So that's exactly what it's saying. Again, it's based on some like random initial like start point, and it's based on milliseconds and so on. So okay, so far I have defined two ways that you can count the elapsed time. For all of them you will see some residues, because each one of them has some specific properties that shows this like residue. But what if you don't really want to see residue and you just want to see like 1 second, 2 second, 3 second passing? You need to add one in a loop, like all over and over again. There's a different ways that you can do that, but there's a one specific way that I want to show you how to do it, because I want to show you a specific function, and that's called a feedback node. So right click, go to structures, and choose a feedback node. Actually, I will put this aside for now and I will show you something else. So add a numeric function of add, and for the y create a constant of 1. So basically you want to add 1 every second to your previous values. I actually found this feedback node by chance. Once I was making a program for my application in the lab, and that's when I was like thinking to myself, what if I could like wire the input and output together, like make a loop with a function itself. Sometimes it's like something that you really need to do, like add something to a specific function over and over again in a loop, rather than like defining so many different things. So I was playing with it, and then I found the feedback node. Here, for example, say that you want to add number 1 to your previous value over and over again. So you'll have 0, and then you have 1, 2, 3, 4, 5, 6, because you are adding 1 count every 1 second. And is that possible with just the add function without like doing all these like things that I explained to you? Yes, it is possible. So what if I wire the x to the x and y? You can see there were no errors. Actually, it didn't generate any error, and actually it brought a feedback node here. I'm going to delete this wire and rewire it so it looks cleaner to you. You can see what it means. It means that it will get the x and y value and then return it to the x, and then add 1, get the x and y value, and then return it to x. Let's go to the help function of this feedback node. And it says that the feedback node actually stores data from one VI execution or loop iteration to the next. So it basically creates a loop for you. I have added the feedback node here, like it just appeared because LabView was smart, and then it figured that you need a feedback node. Otherwise, it's just an error to connect an output to an input. But what if we want to do it ourselves? You just have to add the add functions and the constant of 1, and then connect this to the initial of the arrow direction, and then the output of the arrow direction to the x. So it's just basically the same thing. We just created the same thing by adding the feedback node function ourselves. But you can just wire them, and then LabView will show you the feedback node. I'm just going to delete this part. We have this. And let's create an indicator here, and we call this indicator time count. Bring it here. I'm going to delete this indicator for the tick count, just to have a cleaner space. Now let's run this program one more time. With 3 different ways of counting, you can see these 2 ways are counting with some milliseconds residue, but this is counting differently. But notice that this one is always counting 1 second above, because it starts with 1. It didn't start with 0. Let me stop this program. If I add 0 here, I'll run it again and notice this one. It's not changing at all. Why do you think this is happening? The reason is that the feedback node always starts with 0. Let me highlight it and then show it to you. Wait for the feedback node to start. It starts with 0, get the 0, and 0 is always counting if you don't add 1 here. So feedback node always starts with a 0. That's the initial value for it. And if you add 0 here too, it will be just 0 adding to zeros and zeros and zeros. So that's why I added a 1. But by adding a 1, I will start from 1 rather than 0. So I'm just 1 second above. It's just so simple. You just have to add a subtract here. and then subtract this value from 1. Super simple, right? I guess every one of you already guessed that. So I'm going to subtract value 1 from these values and then add it as a time count. And you can see now I have like 1 second, 2 seconds, 3 seconds, similar to the other methods. So far I have showed you 3 methods that you can have a counter of times based on like 1 second. You can have the counter based on like milliseconds or whatever. So this is based on like 1 second. I have showed you how to count for the time. But there's a very much easier way to do that, and it's super clean. And I'm going to show you how this works now. From the very first videos, if you remember, I was talking about some express VIs, some functions that they are actually inside a blue box that National Instruments built it inside LabView, so it can do a bigger function as a smaller function. Like, what I mean is that it can do a lot of different things by just adding that specific express VI. It's kind of like a sub VI that is running on the background, so you don't have to code everything yourself. That specific express VI does everything for you. So we have this kind of express VI for timing too. If you right click, go to timing, and then choose the elapsed time. You can see it's an express VI because it's inside a blue box. Put it here. It will ask you about the elapsed time. Do you want the elapsed time to be 1 second? Yeah, that's what we want. Okay. And it will create you several nodes on the left and on the right. The left one is like time target, and then on the right you have the elapsed time and so many different things. You can go to the help and read all the nodes, and there are a lot of things that this function can do. But mostly what you will use is you will define a time target and you will see the elapsed time. And you will tell the program to stop once a time target has reached. So you have to put this elapsed time inside a while loop too, because it has to be inside a while loop and run and run and run over and over again. Otherwise it will just run for like that specific time. So you will add a while loop and put it around this elapsed time. It will ask for the time target. So it's actually asking you for how long do you want the while loop to operate. So you have to create a control for it. And then it also show you the elapsed time, so you can create an indicator for it. It has to be an indicator because it's only sending signals out. So you will have the control as a time target and an indicator as the elapsed time. And again, see, we are having an error because this stop button hasn't been wired to anything. The good thing about this express VI is that it has a boolean of time has elapsed. So it's asking you, has time elapsed yet? And if the answer is true, it will send a true signal. And that true signals will go, you can wire it to the stop button here. And whenever a true gets to a signal, to a stop signal, to the loop condition, which is the stop of the while loop will stop. Like in here, if you click on the stop button here, it will send a true value, a true signal to the loop condition. It will stop the loop. But here, instead of like adding a stop, like a button that you yourself will stop the program stop whenever time has elapsed. So this is exactly what we want. We want a program to run for a specific amount of time and finish. So in your lab, you want to measure a pressure for 1 hour, and after 1 hour, you want the program to finish. You don't want to come over and then stop the program. Maybe you want, but mostly you want to just run for a specific amount of time. So that's why you always need a while loop with a elapsed time express VI inside of it. So you can define the time target and you can see the elapsed time, and after the time has elapsed, the program will stop. You can add a time target to this kind of programming too, and add like an if statement or a comparison on all this day. And for example, instead of like having a stop here, you will say, is elapsed time more than 3600 as in 1 hour? If yes, stop the while loop. So it will do the same thing for you. But don't you agree that this is much cleaner and easier and you're not going to make a mistake? I think that this is better. So I always go with this one. At the very first time that I was working with the time loops, I tried to do it this way, but I thought it doesn't make sense. I don't like it this way. I like it this way. It's cleaner, easier for me to follow, and the chance of me making a mistake is low. So let's run this one. Let's say that I want to run it for 10 seconds and see the elapsed time. Notice that I haven't added any wait loop here. I want you to see how it looks. This is how it looks. It will exactly show you the seconds that is passing. So these are all like the same, but it's also showing you the microseconds and milliseconds value too. And after 10 seconds, this one stopped, but this one hasn't stopped yet because we need to manually stop it. You can also add a wait function inside this while loop and then run it one more time, and this way you will see like seconds, exact seconds that is passing. Just notice that the residual of this and this are exactly the same because this elapsed time is based on this function, but it's just in as an express VI, so it's easier for you to model it. As I told you, you can also stop this without having an icon here by defining a time target. I want to show you how it works also. And I will say that is the time count greater than 10? If it's greater than 10, stop the while loop. You can either use the elapsed time, the time count, or the tick count elapsed time. They're all the same. Now let's run it one more time. And both of these while loops should stop after 10 seconds has passed. You can see 8, 9, 10, stopped. So the program stopped. So you can either define it like this by defining the get date and time function and then stop the program and do a lot of wirings, or you can just go with this, which I think is cleaner. This was what I wanted to show you about the time loops. They are really, really useful, and I'm sure every single one of you need to use it for your project. So I hope that this one was a useful video for you. Till next video, see you soon.